Welcome to Prince Maths Clinic, the e-learning solution at your pace and time. Good day and welcome specially to today's class where we shall be looking at differential calculus. It's a special class because it's a special type of differential calculus that we shall be considering in today's class. Do well to follow carefully to see how we can treat the questions that we have on the board so that you can do them on your own if you come across them anywhere, anytime. And trust me, we shall be using a simplified method to do the set of questions we have on the board. The first one says we should differentiate. To find the derivative means to differentiate. So y equals to a to the power of x. So let's go. You are going to state your question a to the power of x. Then when you confront a question like this, take note that this is usually a constant. This a is a constant. Then what you need to do is to look for the natural log of both sides. And the natural log means ln, the ln y equals to ln a to the power of x. So that's the way to be. Then we'll now apply the law of logarithm that says if a log is carrying a power, that power will now multiply the log. So here will look like this. Ln y becomes x ln a. So at this point now we can now differentiate both sides. Now this is the mixture of both x and y. So we are going to use the implicit differentiation to do this. So we know that it's a standard derivative that if you differentiate ln x, you are going to get 1 over x. But here now we have ln y. We have y. So we are going to do dy dx of y. So we are going to do it like this using this method, which is 1 over x. But here we are going to say 1 over y. But because we have differentiated y and not x, we are going to put a dy dx beside it. Good. That's it. Then in this particular portion, remember I told you that this is a constant. This is a constant. Good. So you treat it as a constant. You know, if you differentiate 2x, right? If you differentiate 2x, you are going to obtain 2. The x will go. So if we differentiate this, since this is the constant, this will go. So we have ln a. Good. So to obtain our dy dx, therefore dy dx will now be y times this. So it will now become y ln a. So what is y? Remember, y is a to the power of x. So it means that this is what? A to the power of x ln e. So that is the result. When you see this like this, just write this the way it is, then you put ln of the constant. That is it. So I'm going to write this formula somewhere because we'll be using it to attempt 2 and 3. Now look at the second question. Y is equals to 2 to the power of x. So there's no need to revert the wheel because it has already been created. So just copy what has been created. And what is it that has been created? The solution to the first one we got was what? A to the power of x. You just repeat your question. You just say ln. Oh, sorry. This x should not be there. Ln a. So that is what our result will look like. So therefore, you just say dy dx will just become what? 2 to the power of x ln 2. That's all. That is the result. You just write this, then ln of this. That is the result. Good. So let's look at the third question. We have y to be equals to 4 to the power of 3x squared. So the first thing to do here is to what? Is to make this equal to something. So we are going to say let t be equals to 3x squared. Now I want to differentiate t with respect to x. So if I do the t dx, to differentiate, you take what is in the power, you multiply everything. So 2 times 3 is 6. So you have x to the power of 2 minus, you subtract 1 from the power. So 2 minus 1 is 1. Right? And x to the power of 1 is still 6x. So I'll write it like this. I'll leave it like this. Therefore, we can now say that my y is equals to 4. Remember, everything here is t. 4 to the power of t, right? So this implies if I now do dy dt, I'm not going to apply this formula again because it looks like a to the power of x. Good, this is the constant. Just wait, 4 is the constant here. Good. So therefore, dy dt will now be 4 to the power of t times ln 4. Is that correct? Good. So that is it. Therefore, we can now use chain rule to now do dy dx. So therefore, dy dx will now be the product of dt dx times dy dt. So let me write this first. Dy dt times dt dx. At the end of the day, there will be balance. Why? Because dt, we cancel dt. So you have dy dx over dy dx. And what is dy dt? Dy dt is 4 to the power of t ln 4, right? Multiplying, what is the t dx? 6x. Good. So what do we do at this point? I want to replace back my t. Remember, t is equals to 3x to the power of 2. So it means that this will become 4 to the power of 3x squared ln 4 all multiplied by 6x. Now, you can leave your answer like this, or you can put 6x in front and put this at the back. That is the result to this set of questions. You can pause or rewind to get a better glance at what we have done. So I would encourage you to subscribe to this channel if you are yet to do so, and expect more from us. Bye for now.